Hey everyone, welcome back to the channel. The architecture begins with the development workflow. Developers write and manage code using Visual Studio Code, committing changes to a version control system. This triggers the CI/CD pipeline, which automates the build, test, and deployment process. The pipeline ensures continuous integration and delivery, deploying the application to the production environment with minimal manual intervention, following DevOps best practices for rapid and reliable releases. The deployed application is accessed by users through a DNS service, which resolves domain names to IP addresses, and a content delivery network, CDN, which caches static assets globally to reduce latency and improve load times. User requests are routed to a load balancer, a critical component for distributing incoming HTTP/HTTPS traffic across multiple web app servers. The load balancer uses algorithms like round-robin or least connections to ensure even distribution, enhancing fault tolerance and scalability by preventing any single server from becoming a bottleneck. The web app servers handle the front-end and application logic, serving dynamic content and processing user requests. These servers are deployed in an auto-scaling group, allowing the system to scale horizontally by adding or removing instances based on demand, ensuring optimal resource utilization. They communicate with back-end servers, which manage core business logic, API endpoints, and integrations with downstream services. This separation of concerns between web app servers and back-end servers follows a microservices architecture, enabling independent scaling and deployment of each layer. The back-end servers interact with a database for persistent storage, handling structured data with a relational database management system, RDBMS, or a NoSQL database, depending on the application's needs. The database supports transactional consistency and is optimized for high throughput, with indexing and caching to reduce query latency. For search-intensive operations, the back-end servers leverage a full-text search service, such as Elasticsearch, which provides fast, relevancy-based search capabilities through inverted indices, enabling efficient querying of unstructured data like user-generated content or logs. To handle asynchronous tasks, like sending emails, processing batch jobs, or generating reports, the back-end servers offload work to worker nodes. These nodes operate in a distributed task queue system, such as Celery or RabbitMQ, ensuring that long-running or resource-intensive tasks don't block the main application flow. Worker nodes scale independently, processing tasks in parallel to maintain system responsiveness under load. For observability, the architecture includes a logging and monitoring system. This architecture ensures scalability, resilience, and observability for a modern web application. The CI/CD pipeline streamlines development, the load balancer and auto-scaling enable high availability, and the separation of web app servers, back-end servers, and worker nodes supports modular design. Full-text search enhances user experience, while logging and monitoring with alerting ensures proactive issue detection. If you're building a web application, this design is a solid foundation to start with. Drop a comment if you want a deeper dive into any component, and don't forget to like, subscribe, and hit that bell for more technical content. See you in the next one.